My name is Yu Suzuki from Gifu University, Japan. Today I'd like to talk about high-quality social media analysis using crowdsourcing and machine learning. So first of all, I want to introduce myself. My name is Yu Suzuki. I'm PhD associate professor and the head of Suzuki now. I'm Gifu University. So maybe you don't know where is Gifu. Gifu is maybe Tokyo and Osaka. So between Tokyo and Osaka, it's a very small city, about 10 or 12, largest city. It's a very small city, but very beautiful city. It's very near to Innsbruck because there's a very large bridge and river. This is Nagara River. And the very big mountain. It's similar to Innsbruck. And Gifu is very famous for ukai and cormorant fishing. Ukai is a fishing method where the cormorant, a kind of bird, made to swallow sweet fish. It's a very old event. But many tourists visit Gifu to see this ukai conference fishing. This is the picture of this ukai conference fishing. Very interesting. So if you come to Gifu summer, I will you can enjoy this ukai. And then I introduce my research interests. First is social media analytics, and second is text data mining. Social media mining, we use many methods like machine learning and crowdsourcing, and also game theory, such as mad bandit algorithm or something like that. And the target is the Twitter, mainly the Twitter. And Wikipedia and Wikidata. I did a lot of research about Wikipedia, and I have a present a conference at the Media Wiki Association or something like that. So today I'd like to talk about this social media analytics. So if I did the research of Wikipedia many times, so someone created some Wikipedia page of me. This is a Japanese version of Wikipedia page, so but this is the introduction of me on Wikipedia. So first, I introduced my research. How to get high quality data set is also the problem. So when constructing a practical application, data set is always a big problem. So if we use a data set, we should search many data sets from many data sets. There are many data sets open to public, such as Wikipedia or Wikidata or Freebase. And also the Twitter data via Twitter Web API is also a big data set. Data published by governments, such as data.gov and data.go.jp is also the useful data set. But we cannot research if there is no adequate data set. So if we want to analyze something that is which have no data set, I will not do the research because there's no data. So, but I want to need the data set for processing my research. So I have a budget to make a data set. If I have a budget to make the data set, we should decide to make the data set, generate the data set using crowdsourcing. So this is the overline of social media data analytics. First, this is crowdsourcing system. First, we get some data from the Twitter or something like that, and using this crowdsourcing system, we get the high quality data, labeled data. And using the training data, we construct a machine learning-based classifier. And then, if we get the unlabeled data, so using this machine learning-based classifier, we can get some labeled data, high-quality labeled data. So there are two issues: that how to construct high-quality labeled data sets using crowdsourcing, and the second topic is how to construct an accurate machine learning-based classifier. So today, I'd like to talk about these two topics. Crowdsourcing, I introduced about the crowdsourcing. Crowdsourcing is a framework for constructing undated data sets by workers on the internet. First, I use some crowdsourcing companies such as Amazon Mechanical Turk or Cloudflower or Lancet and CloudWorks in Japan. From these companies, we hire many workers on the internet. So, and then my system gives some data such as tweets or Wikipedia articles or something like that. And the workers label something such as positive or negative or something like that. And to one data, 3 or 4 workers are doing the same data. Using the majority voting, we get the tweets with label. This is the system I constructed. This is called quality data crowdsourcing system. This system is a web-based application using JavaScript and Postgres. JavaScript includes Node.js and Nest.js. If the workers answer, first the workers show this tweet and answer this question. This is a review of something. Are you interested in this review? This is a question. And answer is yes or no. We can change any questions and answers. So then if the workers answer the question, the tweet is changed to the next one. The workers who answer 100 questions, the workers will earn 30 Japanese yen, about 30 cents in Europe. And we can set yes or no questions and also a free text questions. So my research topic is 4, how to keep the quality of outputs of crowdsourcing, because there are many spam workers in the crowdsourcing. And so how to extract the workers, spam workers is an important issue. Second topic is how to improve the accuracy of sentiment analysis. If we use the BERT is a major and good classifier. And the F1 score of the positive and negative classifier is less than 0.8. Up is 1, if so we cannot improve the quality, accuracy of this classifier. So the question is, can multitask learning help improve the accuracy of classifiers? 3 and 4 are skipped in this seminar. So first topic is how to construct high quality labeled datasets using crowdsourcing. So it is my background. We need datasets with high quality annotation, such as using sentiment analysis and review summarization for the product. And we constructed a sentiment analysis dataset using crowdsourcing. We have 535,000 tweets related to electronics. These tweets are related to smartphones, robot vacuums, and brand images of some maker and manufacturers. And the labels are 1, 2, 3, 4, 5. We have 5 kinds of labels, such as positive, negative, positive plus negative, neutral, and this tweet is not related to smartphones or something like that. And assessed by at least 5 workers and aggregate by majority voting. So if the votes are separated, we assign additional workers. And this data set is very huge in contrast of the other data sets. So unfortunately, these tweets are only in Japanese, so everyone can not except Japanese cannot use this data set. But this data set is used by many researchers, mainly in Japan, such as the papers in the ACL, the top conference of natural language, and several Japanese domestic conference like ANLP or DI or something like that. The problem of the crowdsourcing is the spam workers. For example, some spam workers behave only for earning money, 30 cents. So, for example, the workers don't read the tweets and labels the same, only yes or only no. So spam, and there are about 10% of spam workers. So, if the workers randomly select the answers, it's very difficult to detect who is the spam workers. So there are 2 assumptions. First one is minority votes are noise, and second assumption is if a worker whose votes are always minority, the worker is a spammer. So in this case, there are 3 workers and 2 workers decide the tweet is positive and 1 is negative. So the second worker, she is a minority, so she can be a spammer. But this assumption is not always valid if the number of workers is small, because this is there are only 3 workers, so maybe there is the possibility that 2 workers might be a spammer. So if this assumption should be true if the number of workers are high. But the increased number of workers is costly. We should pay more money to the workers, so we use machine learning instead of real workers. So 2 ideas of constructing virtual workers. First, use the outputs of the worker as a training data set. We pick up 1 real worker and answer the question and answer. And then we input these questions and answers and the tweet, and we generate a virtual worker. Second is the user outputs of all workers as a training dataset, then fine-tuning using the other outputs of the worker. First, we prepare outputs of all workers, question and answers and teach, and generates the pre-training model. And then we use the real workers' outputs used as a fine-tuning and make the virtual worker. So I want to know which ideas are better. So we did the experiments. The aim of this experiment is which of two methods is better for constructing virtual workers. We annotate the labels for tweets using crowdsourcing. There are 605 workers and 250,000 tweets. And the task is what's the meaning of LOL, laugh out loudly, warai in Japanese, in the context of its tweets. Sometimes this warai, laugh out loudly is the meaning is very different. Sometimes it's a positive meaning, and sometimes it's a negative meaning. So I use the data set using the using our developed crowdsourcing system. We labeled these tweets to positive, negative, positive, neutral, negative. Negative contains three options: offensive to others, not offensive. Offensive the user themselves. So this is the result of this the result. Each point means a worker. The left hand means the method one without fine-tuning, only the worker. The right one means the fine-tuning. X row means match rate. This shows the real user's accuracy, and the Y axis means predicted accuracy. And from this figure, we can show that the correlation coefficient of real user's accuracy and predicted accuracy is 0.8. This means a strong coefficient. So method one and method two is also good, but a little bit method two is better than method one. And based on the predicted accuracy, we prune the workers using the threshold, and we calculate the accuracy of the outputs in contrast to the rabbit's mean. But in this case, we're finding fine-tuning based model doesn't work well, so we should analyze the details of the results. So first, we conclude we construct virtual workers from real workers using machine learning. Only each worker's outputs our fine-tuning based method. But we compare the accuracy, and virtual workers work well, like the human. The fine-tuning based approach doesn't work well. So there are the topic 2 is how to construct an accurate machine learning classifier. First, I introduced the machine learning, multitask learning. First, there are many neural network-based machine learning systems, and almost all is a single task learning. First, we input the training data and calculate the parameters of neural network and outputs. For example, is there a picture? Is this picture a cat or a dog? We construct a classifier using neural network like CNN or RNN. So in this case, one model and one task. But machine learning this system, there are one model but multiple tasks. We prepare the other tasks such as what kind of ear shapes or what kind of tail shapes. and this is the main task, is the picture, a cat or dog. And then we construct the neural network which outputs the which can answer the multiple questions. So in this network, neural network is very huge. So if we input the training data, if we input the picture, this neural network answers multiple answers, such as this picture is a cat, and the shape is something, and shape or something. So, but there are many research about multitask learning, but there's no discussion, almost no discussion about what is a suitable task for improving accuracy of the main task. Because many researchers do not mention how to decide on subtasks, and subtasks should be related to the main task, or in some literature without reason. And we couldn't find how to find effective subtask. So in this research, we discover which subtasks can improve the accuracy of main task. So we did the experiments. First is the number of subtasks. If the number of subtasks increases, does accuracy of the main task improve? We confirm this answer. And then we, the second one is the features of effective subtasks. What kind of tasks increase the accuracy of the main task? And we use the Rakuten review dataset. Rakuten is Japan's largest e-commerce site, and this is a kind of Amazon. So there is a product and with reviews. We pick up 10,000 names related to foods. And Rakuten e-commerce site is a little strange and different from Amazon. So the name of products of Rakuten contains somehow redundant words, not only the apple, but delicious apple made in Japan shipped today, imperfect product, almost 100 customers certified apple or something like that, a very long and redundant name. So so we construct annotated datasets using crowdsourcing. We prepare 9 workers and annotate all names. Labels is the positive and more than 3 workers select, and negative less than 2 workers select. And this is the main task. That the name of the product affects someone's interest. Because the name is only the apple, but they're very redundant. So the name affects the interest. So the main task is does the name of the product affect someone's interest? And I also prepare some subtasks. First one is, do you understand what it's all? And second one, are there any expressions of solicitation? And third one is limited items. And 4 is evaluations for each product. 5 is features, appeal points. We combined these we did all combinations of main task and each subtask. So, and this is the result of this experiment. And this is a single task, only the main task. This one, from this one to this one, this is only the main task with subtask 1 to 5. And then from this one to this one, we pick up 2 of 5 subtasks. there are so many evaluation settings, and only subtasks and this one, 1, 3, 4, 5, and 1, 2, 3, 4, 5, all of subtasks. When we use 3, 4, 5, especially 5, the accuracy of the classifier improves in contrast of single task. So this is very complex. So I analyze the results. So first one is a subtask with averaging RMSE. RMSE is a kind of evaluation measure. So lower is better. So if we don't use subtask, the averaging RMSE is 0.8. But if we use all of the multitask, all of the subtasks, averaging RMSE will reduce to 0.6, and lower is better. So using subtasks, we can accurately construct the classifier. And this is the accuracy of subtask and RMSE of main tasks. We compare the RMSE of main task and subtask when I use the subtask, when I don't use the subtask, and measure the difference. So this is the results that the subtasks which have a stronger coefficient with the main task. The main tasks are effective. So in this research, we discover which tasks can improve the accuracy of the main task. And the result is when the number of subtasks increase, accuracy increase. The subtasks have the strong coefficient if the main tasks are effective, if the accuracies of subtasks are high. So the future work is the results the same on the other data sets. It's only that the data set I should try to gather data sets or something like that. That's all for my presentation.